Moin! I've electroplated 100 3D prints in a batch, and in this video I'll explain step by step how you can achieve the same. You'll learn how to prepare them, easily apply the conductive coating and uniformly deposit the metal onto the 3D prints. Let's get to work! Today we're focusing on mass production. Starting point of my projects is always a 3D print, and often I use resin prints for that. However, it's also possible to cover FDM prints with a thick layer of copper. In my specific case, I want to create a benchy pin. It needs to be very small, and the LCD resin method is well suited for that. The layers are nicely concealed, and in the end, the pin looks like it's cast directly from metal. The small test worked well, so I can now print a lot more of them at once. After a thorough cleaning in isopropanol, I can easily remove the benchies from the support with a hot air gun. Resin prints needed to be cured, which happens here in the UV chamber. To handle the 3D print well in the copper electrolyte, I drill a small hole in an inconspicuous spot on the print. I insert a piece of 0.4 mm copper wire. I do this now 100 times and end up with a nice little fleet. To be able to electroplate the small prints, I need to make them all conductive. Using an airbrush for this task would be too labor intense for me, therefore I have decided to immerse them in a thin conductive paint. I take a suitable container and filter the thick conductive paint using a resin filter. Sometimes there are small dried pieces in it that I simply don't want to have. Now I dilute the paint with acetone or butyl acetate using a ratio of 1:2. This works well as it can be also used for airbrushing other projects. Next, I take a benchy, dip it briefly into the coating and let it dry thoroughly. This procedure can be repeated, making the coating thicker and more even. This entire procedure is then repeated for a total of 100 pieces. Now we need to assemble the entire thing because we don't want to coat them individually in the electrolyte. That would take way too long. I designed a small jig for this purpose, allowing me to create a loop consistently at the same spot. In the end, it turned out to be much easier to wind the thin wire around a thick wire. Afterward, I thread all the benchies onto a longer thick wire, creating a fully conductive 3D print ensemble. Now let's calculate the required current. I use Blender for this. I display the surface area and multiply it by the number of the prints on the wire. Then add the surface area of the wires. The surface area in square decimeters corresponds to the current I will use. Before we start coating, let's first change into appropriate attire. No, not like that, but like this. Always prioritize your safety and wear sufficient PPE. I always use at least goggles, a respirator and gloves. Alright, we need acidic copper electrolyte. Mine has a pH of 1 and includes a brightener. I always begin with a thick layer of copper since it deposits easily and polishes well. The procedure is always the same. We attach at least one copper anode to one side of the electrolyte. Then grab a regulated power supply and connect the positive terminal to the anode. Now we connect the negative terminal to the 3D print. I use a rotary jig here to ensure even deposition. Very important, I set the current to the calculated strength and the power supply regulates the voltage. This mode is often referred to as CC or something similar. Let me show you what it does. As I move the print closer to the anode, it decreases the voltage to maintain a constant current. This is crucial for a good deposition result. Let the benchies form a copper layer for approximately 4 hours. It's okay to check occasionally if everything is running smoothly, and you can see directly whether it's working or not. The copper shines extremely brightly. Meanwhile, I'm already preparing the nickel bath. Here I need a nickel anode. It is placed in the bath and connected the same way as in the copper electrolyte. Nickel electrolyte is quite toxic, so one should be careful to wear proper personal protective equipment and ideally do it outdoors. Now I rinse the copper prints thoroughly in distilled water and immerse them in the nickel electrolyte. I let them coat for 5 minutes, using approximately 2 volts. Afterward, we have beautiful nickel benchies, the foundation for gilding. The nickel creates a diffusion barrier, preventing the gold from turning rosé gold over time. Caution is advised with gold electrolytes. It must not come into contact with acid, as it can break down the cyanide complex, resulting in the release of highly toxic fumes. Therefore, I always rinse with plenty of fresh water between the electrolytes. Like nickel, gold electrolyte deposits very quickly, and the longer I leave it in, the more golden the surface becomes. Now I rinse the print again in fresh water. Honestly, I collect all electrolyte residues in separate containers and take them to the recycling center. It's the right thing to do. Look at this gold. Well, now I have 100 benchies in copper, nickel and gold. You could arrange them as a colorful bouquet somewhere, but now I'm harvesting the individual pieces with a side cutter. One of the most satisfying things I've ever done with electroplated 3D prints. I could do this forever. I've decided to turn all these benchies into pins and give them away. I now attach small pins to these prints with metal glue and let them dry nicely. Now I print barcodes and cut many pieces of cardboard, and voila! I can create little business cards. In the end, there were quite a lot. And they were all distributed. I kept one for myself and it now has a permanent place on my lab coat. If you want to do me a favor, comment on this video, like and subscribe and all that jazz. I thank you very much for watching. Until next time, tschüss.